There we go. Hey, welcome everybody once again to Astronomy Daily Live. Ding, we hear the bell. I must be live. So yeah, hey everybody, welcome. Nice to have everybody back today. Those of you who are coming on in, maybe seeing this a little bit later, whatever it is, welcome. Howdy. Here we talk astronomy and space and science and all kinds of nerdy things. I always aim for about an hour or so each and every day, but it usually goes over an hour because this is astronomy and this is my passion, and so I think about it a lot. And so what you're getting here in this live stream are just my thoughts made so you can hear them, right? So that's it. It's I'm not necessarily here to teach anything or to communicate any kind of message or knowledge or anything at all. I've been doing astronomy my entire life, and I've done it at all levels. And so I've got I don't think I have a very thorough knowledge of sort of a broad spectrum of astronomical things, but I've been thinking about these things and looking at these things for quite a long time now, and gotten relatively familiar with most things, and just absolutely love it, and it really starts with curiosity. And when I was a kid, it was I was just absolutely fascinated by everything, and so I'm like, what profession, right, is involved in the study of everything? And that, of course, is the science of astronomy. So we look at everything, right, from subatomic particles all the way up to objects the size and shape of the universe, right? And we've got our noses in everything, every single thing, right? So that suited me just fine as a kid. It's like, okay, I'm going to do astronomy because I want to know everything. and luckily, I don't think that we're very much closer to knowing everything than we ever have been. So I don't know if it's possible to know everything, and if it is, it's like, well, but once you know everything, that seems a little boring to me. So I don't know. Anyway, before I continue to ramble on, I wanted to check the chat really quick. Good, excellent. And so I just wanted to say howdy to Bobby on the panel. Hey, what's going on?
Nothing much. Man, it's been raining all throughout the day, and nowadays we got that cold front coming. 54 degrees. North at 5, humidity at 76. Wow.
Yeah, that's the storm that blew through here a couple of days ago. So yeah, it was blowing due east. So man, it's gonna get you.
Yeah, and it's also a good time to get yourself a new computer and probably an SDR play, because with the new that new proprietary software that's meant for the SDR play boxes, Now it's got that scanning function right now. Jiz was
Oh,
just
wow.
demonstrating it.
Oh, okay. All right. Yeah, I'll have to check that out for sure. All right. Well, I've got the coffee tonight, a little bit left here. It's getting a little cold, but it's still okay. It's still all right. So cheers to that. And then, of course, I've got the usual hydrogen hydroxide here, the HOH, the well-balanced molecule, both an acid and a base at the same time. I just don't know how that happens. Pretty amazing. So, all right. Well, cool.
You know, it's kind of like a bit strange. There's 4 people and it's just me and you.
Yeah, is that strange?
I know. Like, come on, people, talk and stuff, but don't be an idiot.
Well, you know, that's okay. You know, this live stream is for everyone, and that includes those that you know just want to observe. You know, observation is a very very important aspect of science. Of course, you know, you have to be very very observant, and you have to be able to look at things from different points of view, different perspectives, in order to get, you know, sort of a broader understanding, right? So
I should just say, don't be scared, don't be shy or anything.
Oh yeah, no, but you know, if that's your thing, that's all right, because you know that's what this live stream is about too. Is just gathering together in whatever kind of capacity is chosen, and isn't it amazing, right, that we can do this for the first time in history, right? We're doing some really really amazing things in terms of connecting, and you know, we're about as complex as the rest of the universe is, right? So we've got some pretty sophisticated things that we can do, and so, you know, who's to say what is the best way, you know, in terms of interactions and all of that. So yeah, you know, if you want to stay hidden and just listen and watch, I think that's absolutely fantastic. This is the place for you, for sure. So cheers to being invisible.
Yeah, got the faucet water.
All right. Well, cool. So so yesterday's Obs-Session was a blazing success. I had two goals. The first goal was to get at least a couple of hundred images of the Messier 64, Messier 46 region, a nice open cluster just east of Sirius. So, you know, in a nice position right now, right at the meridian, you know, the highest up it's going to be in the sky. So some good data there. Use the blue filter this time. So now I have M46 data in blue, green, and red. I've got them all, and so now I just have to reduce the data, which means I have to create, you know, my calibration data, which is essentially the flat fields, which are applied to all the data that is taken that night, and then the individual master darks. So so those two things are applied excuse me, to the raw data, and what those calibrations do, of course, is they remove all the systematic signal, right? So you know, all the thermal. Oh, there goes the kitty. All the thermal electrons, all the differences in sensitivity across the CCD chip and along the optical path, all that gets removed from the raw data. To what you have in the end is calibrated science relevant data at that point, which can then be measured and you know, done with, you know, whatever you're going to do. And so yeah, so that was a successful run. I got a couple hundred images, 4-second long exposures. The tracking was really really nice last night. It was probably some of the best tracking I've seen. During those 200 exposures, I had to make just a couple of minor adjustments. It stayed right in the field of view. You know, I mean, it moved around a little bit, and sometimes, you know, it decided, you know, to wander, right? And so, you know, I have to pull it back. I had to pull it back a few times over those 200 images, but that's unfortunately kind of unusual, because most of the time I have to sit there, you know, almost every image correcting. So, I mean, I'm exaggerating there a little bit, but, you know, I've got to be on it, right? Hey there, Blackie.
Hey, here comes the little boy, here comes the big boy.
Eating your face.
Yeah.
That looks like a happy puppy for sure.
Yeah.
I
wonder why it's not changing though.
There it goes. That is quite a collar he's got there.
Oh yeah, my uncle got that at a local Walmart and stuff. It's kind of like all that, kind of like a bit spiny bling bling and stuff.
Yes, absolutely. It's got a little bit of bling to it.
Yeah.
That's
the
a
one
happy
that
baby.
we had, it was one of those with the clip. And
yeah.
It kept on going off of him, so we thought it was going to be too small for his big neck. And we tried to give him this one.
Nice.
And it looks like it's holding pretty darn good.
Yeah, and it looks great.
Yeah.
Very cool. Very cool. Anyway, so that was the first goal of last night's Obs-Session. The second goal was to get some engineering data on doing subframe exposure. So instead of grabbing the entire image, I can actually specify a box size and a location, right, on the chip, and just extract those pixels instead. And so the goal last night was just to see how easy that is to do, and how easy is it to have a, you know, even a narrower field of view, right? I ended up taking a series of images that were 80 pixels on a side, grabbing the 2x2 binning. So you know, however you want to think of that, with 2x2 binning. it's 80 by 80. If you were to sort of extrapolate that outward, right, that would be exactly the same as a 160 by 160 with 1 by 1 binning. So that field of view is probably probably a little big. So probably what I should have done. I mean, I think I've got enough confidence and knowledge that it isn't going to be hard, to set this up sort of on the fly. But so yeah, I think that everything that I saw looked just fine. I was able to easily keep my target stars in that smaller field of view. So I don't think I'm going to have any trouble doing that with any of those kind of narrow field observations. And the thing that makes it really, really great, right, is that because I'm extracting such a small portion of the chip, the download time is like super fast, right? It's like super, super fast. So, I mean, it's less than a second, right? It's definitely less than a second, maybe about half a second or so. With 80 by 80 pixels, which, as I said, I think with 1 by 1 binning, 80 by 80 is probably what I should go for, because I've got each of my pixels is about 0.93 arc seconds in size, so almost an arc second, right? So if I have 80 pixels by 80, then that's 80 arc seconds on a side. And I already know that Europa and Io are going to be about 50 arc seconds from Jupiter. So that should, put those guys in there really, really, really nice.
Now, what we're talking about Jupiter again?
Well, this, I'm sort of doing preparations for these possible Jupiter observations that I'm going to be doing, well, that are going to be occurring starting about 10:48 UTC today. So what, in about 6.5 hours or so from now, we've got Europa and Io moving into the shadow of Jupiter. But from our point of view, right, Europa is still actually there. It's just being blocked by Jupiter, right? It's going through Jupiter's shadow. So we could still see, I mean, if Europa was illuminated in some way, we could still see it, right? Jupiter itself hasn't moved in front of it yet. Only its shadow has, right? So there have been these observations. I think taken with HST, but I don't remember exactly. But anyway, they were seeing aurora on Europa that were pretty bright, but I don't know how bright. So I'm just kind of interested, and the other thing that makes me confident that if I can see them, I will see them, is the fact that every single time they looked, right, and they looked at least 10 times, maybe even 12 times. We can find the paper again. Every single time they looked, they saw what they are thinking, is some kind of aurora on Europa. So So the fact that every single time they looked, they saw one, tells me that when I look, one will probably be occurring, right? Now, whether I see it or not with the scope is, who knows, right? But now is the season to be looking for these kinds of things, because Europa is passing into the shadow of Jupiter.
Hey, Chuck.
Who's in the chat? Chuck?
Yep.
Oh, cool. Very, very good. Hope
Yeah,
everything's
I
well.
gotta refresh the chat.
Refresh the chat. Yeah, it's a slow chat tonight. That's all right. No worries here. I think it's great that anybody bothers to come in here. So I think that's awesome. That's why this particular YouTube channel, this particular live stream, was a success. The very first live stream, I achieved my goal, right? So every single day after that was just like extra, right? It's like extra icing on the cake, right? So yeah.
I remember you with just a microphone. You just like a big head, and
just a big head, yeah.
Yeah. And now here you are. You got a 720p webcam. We can see your scopes. We can see the keyboard. We can see the books. We can see the discs.
Yeah, yeah.
Sometimes you do see me.
Absolutely. Well, most importantly, right? Anyway, so hey, there's a Deep Sky Dude. Hey, dudes.
What's up, Deep Sky Dude?
Very cool. Yeah, it's and that is one of the ongoing goals of this live stream is to always try to find ways to get better, right? And so that's always in the back of my mind. It's like, what can I do, to improve this, make it more, participatory, make it more, even more relaxed, right?
That's the same way I found Cosmic doing his show, Chuck, through the shortwave show.
Yeah. It Gilles helped a lot, and he continues to help a lot. So every single time I get on, he mentions this live stream, and it's like that is just far out. Yeah, that is just very far out.
He was the one that just coming back into the radio hobby of HF listening, BHF listening, and UHF listening.
Yep.
And speaking of BHF, UHF listening, I did capture that NOAA 18 imaging satellite and caught a great image.
Oh, very cool. Very cool. You'll have to share it with us at some point.
Yeah, but I need to I need to try to get the image again and stuff, and
okay.
And what I'm gonna do is save it.
Right. So anyway, last night's observing run was very, very successful, and I got some. I think I got some pretty good data with the Messier 46. As I said, I've got to run it through the grinder and everything to see. But one of the interesting things I wanted to just point this out, because it's so strikingly obvious. At least it is to me. Let's see. Let's go over. I'm going to show you my Discord
server
over here because I posted some.
I think you're still on the Radio Hobbyist server, right? My server.
I believe I am. I haven't actually been over there in a while, but okay. Yes, I am definitely a part of that. All right. So I'm going to share my screen, and we're going to go over here. So these are single image, 4-second exposure shots of the M46 region. You can see, you know, some of the stars in the cluster. You can also see the Planetary Nebula that I believe is in the background, right? I don't think it's in the foreground. I think it's in the background. But what I want to point out is these 4 stars, right? These 4, see those 4? And see how they're all sort of equally bright. You know, they're you know, maybe this one's a little bit brighter than this one, but they're really close, right? Here, we can open this up a little bit. So see, I mean, these 4, they're basically the same brightness, right? Well, that's using the red filter, right? So if we look at those same 4 stars with the green filter, you see how they don't look the same brightness anymore, right? This one's a little fainter than this one, and these 2 are about the same. This one's almost right in between that one and that one. So, you know, their brightnesses are different. Well, this is using the G filter, right? And there's that little planetary up there again too. But if you look at the data that I took last night, now this data is still in a raw form, right? So it's kind of messy looking, but if you look here, you can see the 4 again. Look at this dude. So this is looking at the stars using the blue filter, right? So what that means is that this star is very faint in blue, and pretty bright in red. So that is going to turn out to be a very red star. Very red star.
So is this image colorizable or no?
No. But what I can do, and what I'm going to do, just because I can, not because I actually see any scientific value in it at all, but now that I have this blue set of data, I can actually combine those 3, red, green, and blue, to come up with a color image. And for sure, this guy is going to look, you know, either yellow or red, for sure. So yeah, I'm sort of anxious to see that. And as you can see the planetary here. This, you know, last night I had a lot of moonlight.
Welcome Tim Robinson in the chat.
Hey there,
join
Tim.
us in the panel.
Come on in if you want, Tim. So last night the moon was out, so the sky was considerably brighter than what it is when there's no moon out, right? If you sort of look at this grayish background here, right? Now, a lot of that depends on, you know, the kind of stretch I do, but, you know, you can sort of see the contrast, or, you know, lack thereof, between the Planetary Nebula, which you might actually be able to see a little bit easier if I zoom out a little bit, and the background. You can see that there's not a lot of contrast there, right? As opposed to this data, which was taken with no moon out. You can see that the contrast here is much higher, much higher. So what that means is that I've got a much darker background sky here than I do in the data that I took last night. But that's okay.
The same CCD camera Chuck Dagger was asking. Yes. What kind of camera is for the RGB? That was your CCD, right?
Yeah, well, the CCD camera itself is monochrome, right? It's just sensitive to light. So the more light there is, that gets digitized into a number, right? And that number is stored in a piece of memory and thrown out as a FITS file eventually, right? So that's all these are, is just measurements of brightness on that pixel. That's all it is. So yeah, what I can do though is I can throw some kind of a filter in front of this, so only certain bands of light are let through, and everything else is reflected reflected away. So yeah, so I've got R, G, and B filters, which are definitely not scientifically standard. But what I can do is I can take those values and transform them to scientifically valid photometric values, like the Johnson-Cousins photometric standards, UBVRI. RGB is essentially equivalent to R and V and B in the Johnson-Cousins standard. So yeah, so I can transform them, turn this into scientifically valid data, and then I can compare my measurements to how bright these stars are compared to a standard established catalog. And so far, what I found with my green and red data is that for stars brighter than about 12th magnitude, I'm getting less than 0.5% difference in terms of accuracy. Those particular data sets I saw out to about magnitude 14.5. I could probably see and identify stars down to about 15.5 or 16. But I wanted to take it easy with the software, so I just had it pick out the bright for sure ones, and those went down to about magnitude 14.5. And at 14.5, I'm getting an accuracy of about 1.5%. So in terms of scientifically valid, oh yeah, it's fine. It's fine. And look, if I have to quote unquote limit myself to 12th or 13th magnitude, man, there is so much to do. Yeah, that's just that's an easy answer. So anyway, this was last night's data. As you can see, kind of dirty, kind of speckly, and all that. But yeah, it's pretty amazing how much fainter this star is compared to the other ones, which you can now see here are pretty different. So it's just really neat to sort of see differences in magnitude, which correspond, to colors. Because once we have an understanding of the colors, all kinds of things pop out of the models in terms of temperature, in terms of luminosity, in terms of distance, in terms of size. All these things can pop out of the models once you have some basic photometric data, right? Like the difference in brightness between the B filter and the V filter. Once you have that information, as I said, all kinds of things can pop out. So it's pretty good. And I'm pretty happy with the tracking here, right? This is a 4-second exposure, and we're seeing some pretty faint stars, right? But the thing that I like most, right, is that if you look at the faint ones, right, the brighter ones tend to sort of spread themselves out over a lot of pixels, depending on the stretch here. But you can sort of, it's kind of neat. You can sort of see. Is that as high as it goes? Okay. You can see the individual pixels here. Isn't that cool? And so if you look at the faintest ones here, right, they're basically sitting on 1 pixel, right, which is exactly correct, right? Exactly, because I mean my conditions are that with 2x2 binning, I've got pixels that are about almost 2 arc seconds in size. So yeah, everything on here is basically a pinpoint. It's just I've stretched it a little bit, so we're looking at the bottom, and so it tends to spread out at the bottom a little bit. That's due to the optics, and there's not much that can be done about that, except just make sure you take it into account. So anyway, that's where that is.
Hey, Tim.
Hi, buddy. All right.
Hey there, Tim. What's going on?
Not a lot. All doing good, though.
I think that's a good thing.
How are you?
Good. Really, really good. Had a good Obs-Session.
Cool.
I think I got some good data here, so I'll be running it through the ringer here over the weekend, and I've got to stack 200 of these images, right? Oof. So I produce these kinds of things instead. So yeah, it's just a matter, it sounds like a lot of work, but it's really not. The code that I've got works pretty well, and so yeah, I'll be able to stack these no problem at all. So
cool stuff.
Yeah, and then we'll see what happens. This little project here will give me a lot of confidence in terms of data quality, and that's sort of what I'm looking for. Is how good can this system actually perform? So and this is these kinds of exercises are definitely helping trying to quantify that a little bit. So yeah, fun stuff.
Very good.
Mm-hmm. All right. So that's happening. Yeah, these mutual events at Jupiter. This is sort of the season for those kinds of things. And there's going to be an opportunity today, starting at 10:48 UTC, to observe, as I was saying before, Europa and Io moving into the shadow of Jupiter. You know, I've been wanting to see if I could see this or not, and maybe it's the fact that it looks like I'm going to be clouded out is making me try to rationalize not making the attempt, because I realize that is actually going to be like like 4 in the morning.
I think it's time you to update your Fedora.
What's that?
Check your notification. You had
something on top of the screen. Yes. Oh, yeah. I have to update. I have to update for sure. Anyway, so yeah, that is going to be happening, but I realize that it's going to be happening at almost 11 hours UTC here, which to me, I'm 7 hours behind UTC, so that's 4 hours UTC, or I'm sorry, 4 a.m. Here in Arizona. And that really doesn't allow for enough time to sort of make a full observation of those events. The sky begins astronomical twilight at 12:15 UTC, or I'm sorry, 0 hours 15 UTC, right? So yeah, I don't even think that I'm going to try. Yeah, I'm not exactly sure. We'll see how it goes. It's supposed to clear up by 3 a.m. local time here. It's supposed to clear up, but the humidity is supposed to be way beyond what is possible. Yeah, something like 85 or 90% is what's expected. And if I have those kinds of humidity conditions, I'm not going to be able to see anything through this scope, right? It's going to be completely fogged over. So I think what I'm going to do is I'll set my alarm. I'll set my alarm for 3 a.m. local time, right? And I will stop sharing here. I will get up. I will go outside, grab my temperature meter, right? You know, thermometer thing that has the humidity on it, and see what the humidity is at that time. If it's you know, in the 60s, maybe early 70s or lower and going down, then it's like, okay, well, maybe this will happen. Then I'll come in, I'll look at the satellite loop, see what the clouds are doing up there. If it looks good, then I'll have to decide if I'm going to do it or not, because I'm not going to see the whole thing. And yeah, I don't know. I mean, we're not really going to see the whole thing anyway, because both of those moons are going to be moving behind Jupiter at that time. So yeah, but I don't think I'm going to be able to see it. I think the sky is going to be too bright, and I'm not going to get good data on it. So I think the timing for this one is about an hour. It's an hour too early, right? If it was 9:48 UTC, that would have been much better. So you know, we really have to work on these times of these events because I think that they need to be made more convenient. Because it's really a royal pain, to have to wake up at 3 a.m., 4 a.m., to look at this dumb event, right? It's very inconvenient. We want it such that we can just very, very easily walk outside and look at it, right? Not have to wait till 4 a.m. to do it. Yeah.
Yeah.
But since it's already almost 4 a.m. where Tim is anyway.
No, actually, it's 2:45.
Yeah, see? That's almost 4.
75 minutes.
All right, well, cool. So yeah, I guess I'm going to get up tomorrow early and just evaluate and see. But I'm thinking that it's probably going to be a no-go. That's my guess at this point. I don't think it's going to clear up, and even if it does, the humidity I think is going to kill me. So it's like, but there's a lot of these events, right? There's a lot of these events coming up. I'll show you this again, like really, really quick here, I guess.
Yeah, check it out. It's got some cloudy conditions.
Cloudy conditions. That was a pretty good one, Tim.
Sorry?
That was a pretty good one. I'll give that about a 6.5.
Oh, cough.
You gotta do better. Yeah. I'm just saying.
That's a British cough. Looks like a sneeze.
I missed that whole thing, Bobby. What was that again?
Why is when a British coughs, it sounds like a sneeze?
Oh, weird. I actually coughed into my shoulder, so it wasn't too loud on the mic. Unsuccessful attempt.
Unsuccessful. Okay, well, as you can see here, I'm looking at the Europa Eclipse events, and this is the only one that's partially viewable until the 10th of April, right? Now, the 10th of April one, I think, is going to be a pretty nice one. So, yeah, the more and more I think about this, the more and more it's like, I don't know.
Hey, Patrick.
Hey there, Patrick. I guess
Hello,
it'd be
Mr. Manny.
I guess it'd be a nice exercise, but yeah, I don't know if I'm going to do it or not. I guess it depends on how clear it is and how cold it is. It's supposed to be in the 20s here Fahrenheit. So that's what about minus 3 or 4 C. That's a little cold. But there are 2 in April, 2 opportunities. So we'll see how that goes. So, yeah, there are still some opportunities here. Here's EO's March events, right? So this is just EO going behind Jupiter. There was one on the 9th of March, which I missed. And the next one looks like it's going to be on the 1st of April.
April Fool's Day.
Yeah. One of my favorite days. We'll see how that goes. Yeah. We'll see how that all goes. I have no expectations whatsoever on that kind of thing. So, all right. Well, let's see what else is going on. Patrick Manny is lurking. Good. Nice to see lurking around. Oh, Chuck, cool. So you get on to AAVSO and actually measure light curves? That's very cool. That's very, very cool.
What's AAVSO?
AAVSO is the American Association of Variable Star Observers. So this is a yeah.
No need to explain more.
Okay. It's just a group of enthusiasts who really like observing variable stars, and so they actually collect data, and they have it in a database, and it's great. It's a great organization. They've been around for I don't know, decades, right? So they have lots of good data. We've looked at light curves here from the AAVSO. If I want to look at any kind of variable star information, right? Actually, one of the projects that I'm trying to do is variable star observations, looking at like eclipsing binary stars, and other kinds of variable stars. So it's all really neat, and it's nice to be able to collect my own data and know that it's probably accurate. That's a very nice feeling to have. So, all right, excellent. So let us move on. Trying to think of where we should go. Here. Messier 46. I think I never remember the name of this planetary nebula. It's 2438, I think. Yes, 2438. So yeah, it's just sort of a bonus object. Since it's there, might as well collect some data on it. It's could be useful. I haven't measured the signal to noise of these yet, but they look, I think, hopefully usable. So we'll see. Still have to do that kind of analysis. So oh yeah, well here's the cloud situation. I can try to reload this and see if it'll let me. But I'm about right about here. So as this loads, it'll go away. So I'm right about here, and so we've got this bank of clouds kind of moving through, but they're moving kind of slowly. So don't know if we're going to get a gap here or not. Don't know exactly. So yeah, that's kind of gloomy looking. And then these guys, they come out with a it's a, I guess it's sort of a moderately reliable forecast, but as you can see, so here's the local time, right? Here's the local time. So you can see that according to this, at least by 4 a.m., it's supposed to be 10% covered, right? 5, 6 is supposed to be a little bit more covered. So, and then we've got the wind blowing, possibly going, to 90%, right? And it's going to be in the 20s Fahrenheit. So I'm just not happy about any of that at all. So
this Whale, or is that something that you got a name, or that's like the closest observatory?
That is the name of I guess what you would call my observatory. So yeah, it's called Way Away, and that it is. It's way away.
I mean,
It
how
is
do you
way
get your
away.
own clear sky chart? That's what I want to know.
You have to ask. That's the secret. Yeah,
Okay.
you just have to ask. I have absolutely no idea. I asked. I think I don't know if you have to fill out some kind of a form or something. I forget exactly. So they might run you through the ringer, but I don't remember. But yeah, I think I just asked, and
they just gave it to you.
I think I'm not quite sure. I'm not quite sure if they asked me anything or not. I don't remember exactly. Anyway, yeah, but this is mine, and this is based on the geographical coordinates of my location, which yeah, and so this is the forecast for that location. And as I said, is it accurate? It's probably sort of accurate. But yeah, this is the time of the event. And
See you, Chuck. Take care.
What's that?
Bye-bye, Chuck. Take care, buddy.
Oh, yep. See you later,
Chuck.
Thanks for coming in. Anyway, so it doesn't look promising at all. I'll get up. I'll take a look, but I'm not too enthusiastic about this one. I think I've got to turn my energy to the next series that are coming up in April. So yeah, that's the astronomer's life. That's how it goes. So yeah, I wonder. Well, yeah, I don't think we need to get into that. Let's see. Trying to think of what else we can do here. Let's see. Well, let's look really, really quick and maybe give a final close to the constellation of Leo. We've been on for a little while here. Let's see if there's anything just on the Wikipedia page that sort of pops out as something moderately interesting. Regulus. Tau Leonis. Bright variable star R Leonis, which we talked about, which we looked at. We looked at Wolf 359. Yep. We looked at 60. Well, we looked at 65. I don't think we looked too hard at 66. So there's a notable gravitational lens known as the cosmic horseshoe is found in Leo. I've never seen any of this gravitational lens data from HST data. I assume that this is HST data. Let's see if we can find this in the HST archive.
I didn't even know that
existed.
existed.
What's a gravitational lens, by the way?
Gravitational lens is this phenomenon where you have this very, very massive object between you and a background object, and the light, as it passes through this larger object, that light actually gets bent in an optical sense, and creates these amazing optical, I guess you'd call them, structures that is using gravity as the lens, as the thing that bends the light around. Yeah, these are real things as far as I know.
So it's actually the gravity of the object in the foreground that causes the distortion, and the lens picks it up.
Yeah.
Right.
Yeah, it's crazy. Let's see if it comes up. Cosmic Horseshoe. Let's see if it will resolve. Ooh, it is going to resolve. Interesting. I wonder if this is it or not. Hasn't been looked at much. Let's look. Ooh, I don't see anything there. Not seeing anything there. This looks like the same thing, just a slightly longer exposure, slightly shorter exposure. Huh, wow, I'm not seeing anything there. Oh, there it is. All right, yeah, there it is.
That's the same object.
Yeah, that's the same one as this. They've just, they've colorized it and whatever. But see, there's a bright star right there. There's a bright star right there. So yeah, looks like.
I'll be darned that they use professional image manipulations to colorize that horseshoe.
Oh yeah, and that's all right. I mean, this has some scientific value. This, not so much, but it sure looks nice.
So those that think this is a CGI, you are a CGI.
Yeah. Well, this is false color, right? So it isn't necessarily true color. But nothing has been either added or removed. We've just added color for emphasis. And that's what color does, right?
Plus it pretties it up a lot.
Absolutely. But, I mean, see, now I look at this and I think this is at least as spectacular as that, right? I mean, I think this is just absolutely fabulous, right? But yeah, so that's what's happening here. Is this at least the theory goes is that this object here is between us and an object almost directly behind it, right? And that's what this object is. So the light from the background object is moving towards us, right? At least some of the light is.
Now, is it safe to go into those lenses, or still deadlier as the black holes?
Well, I mean, this is a galaxy here, right? So you could very, very easily fly through a galaxy and never hit anything at all, right? So no, there's no more danger moving through this galaxy than there is moving through ours. So yeah, I mean, it looks like everything is really, really close. No, not really. Pretty spread out. But it's just the fact that
research in the future be done to research black holes, if you can find one?
Oh, well, that's an ongoing thing, right? So everybody's been crazy about black holes for quite a long time now, and the search for them continues, right? No one has ever yet seen a black hole, not to my knowledge. They've seen objects that seem to have a lot of mass, right? But does that mean that there's a lot of stuff there, or just a lot of energy there, right? So I don't know, but yeah, the search for black holes and sort of the theoretical study of them, that's been going on for decades. Yeah, quite a long time. But yeah, this apparently is caused by this effect called gravitational lensing, and this object, whatever it is just being wildly distorted by the gravitational lens caused by this probably pretty massive elliptical galaxy. So pretty amazing, and there it is, right? That's hot off the press here. So let's see. So that was actually an infrared image, right? Let's look at another infrared image of the same object, but even redder, right? Even more into the infrared. Cool. These guys all behind it and everything. That's pretty nice. So, okay, so that one's even redder. Then they go into the almost, well, yeah, 4771, that's pretty blue. 8048 is pretty red. 5885 is, yeah, sort of yellowish green. So, yeah, these three.
So you should be able to hold those images and try to colorize them yourself.
I certainly could. Do you think I should?
Why not?
Up to you.
We can certainly try, I guess. All right. So let's see. This one is the reddest one, so let's call that one the red. So let's see. We're going to pull this up. And then we'll save it as something here. Come on.
You don't have wget on your Fedora, right?
Oh, I do. Yeah.
You just don't use it.
I just don't use it. Not as much as I should.
You should give that a whirl.
Yeah. I certainly could. It'd probably be a lot easier than this, but that's all right. I'm not sweating it too much. 16. Okay, so this is the red one. We're going to call him red. Come on. There you go. Okay.
There it goes. All right.
So here's the green one. We'll call him green, GRN. And here's the blue one. So hopefully these stack relatively well. I think they probably will. ELU. All right. So now let's go over here. We will load them into GIMP and see what we get. Let's load the red, I guess.
Now, I wonder if you can batch select them and they will all load up in GIMP.
Well, they will, but they won't add up as layers. So I load in one, and then I open the others as layers, and that seems to work pretty darn well. Oh,
They want to do that.
Don't Don't freeze my machine. Please don't freeze. Let's see, where was I going here? We're going.
I don't see the splash screen.
There we go. Okay, so there's red. So now let's open his layers, and we'll grab green and blue. Okay. So now let's just put these in order. Probably have to go to RGB. Okay, so now let's invert each of these.
Now, when you do RGB, it should do that for all the images, right?
Correct. You are correct. Invert that guy. Invert that guy. Okay, so now we're all that way. So now let's make this one red.
Do you have to have them as screen or no? Or they're okay?
Eventually, yes. I'm going to do each one first. So there's the red one. Here's the green one. And here's the blue one. Let's see what we get. Let's see if they're stacked. Okay, so now we can do this, and as Bobby said, we can go to screen, and that'll add them, sort of add them together. Looks like it's stacked pretty darn well.
I think that's excellent how that works out.
Because, see, I can remove the blue, can remove the green, can remove the red. So, yeah, wow, those are stacked really, really well. So, there you go.
That is a very good picture.
Yeah, yeah. Can probably turn that into a puzzle. So yeah, actually, that is a pretty good shot.
Content you get from NASA and stuff are public and open base, so I think it's no holds barred unless NASA says something.
Oh no, these things can be used for anything you want, including commercial stuff. The only thing that they ask is acknowledgement, right?
Yeah, give them credit.
Give them credit.
Okay.
And that's easy.
Now, one thing that you've been wanting to do, but you're yet to do it yet, is try and get some Kepler data. When that's going to happen?
Oh, some Kepler data and some tests data. We need both. Too. For sure. So, well, I think that's a good idea. Probably should look into doing that soon. As you can see, I'm messing with the brightness and contrast here. You can also now this poor machine is being brought to its knees here, trying to do this for us. You can also do there's some automatic things that are sometimes interesting, sometimes not. This looks like some kind of internal reflection or something. Might be due to this bright star. Hard to know. That didn't really do anything too interesting. Let's see what these other ones do. White balance. Yeah. Not really.
I liked it better if you was doing it with just regular and stuff.
Yeah. I think just playing with the brightness.
Just regular brightness.
Yeah.
So
yeah, that's a pretty scene, for sure. And that's this is just sort of uncleaned up HST data, right? I mean, obviously they took this and somebody with the right tools got to do that. So pretty good, but it's definitely the same data. You know, they have it rotated around a little bit and all that, but it's all there. Let's say 200. Let's go maybe to 150. And I can rotate it to rotate clockwise. Of course, it's going to be in the wrong place, but that's okay. We know where it is. Let's go to 150. So compare that we just made here to that. So theirs is a little darker. I can darken that up a little bit. Yeah. Anyway, fun stuff. Yeah, I totally agree with you guys. I think this is a great thing, maybe just to put in our back pocket and see when it might be neat to pull it out.
I just want to know why you didn't save it. That's what I want to know.
Oh, I am definitely going to save it for sure. Would you like me to do that just to make sure that I actually do it? There we go. I'm just going to save it just like that. I'm going to call it red.xcf. Bam. And actually, I think I'm going to save it as just the grayscales. That. Yeah. So I'm going to save it as the grayscales because then I can play with the colors later on. But yeah, so nice. So that's called the
You should have used
cosmic
save
horseshoe.
as. You should have used save as because that's when it will replace.
Oh, I did already.
No, you didn't do. You just did save. You didn't do save as.
I did save as first.
Yeah, and then you just do save, which replaces the color with the grayscale. Correct.
That's exactly what I wanted.
Okay.
Precisely. All right. Well, that's kind of neat. I didn't know that was in Leo. Let's do one more quick thing. I wonder. Let's see. Well, these will give us the coordinates. So 1148, 33, and plus 1929, 36. Yeah, that's sort of in Eastern Leo. That's almost into Virgo, almost. So yeah, pretty close. Let's oh yeah, we can do this. So, oh, come on. Here we go. So 1148 and plus 1929. So 1148, well, 11, here's 20, 40, 50. So here's 1150 right here, right? And what was it, plus 1929? So right about there, yeah. So way over in Eastern Leo, just above the nebula, it looks like. So cool, kind of neat. Kind of neat. Well, that is definitely a photo worth keeping around. And just look at all those galaxies. It's just, oh man, pretty astonishing. Pretty astonishing. And yeah, you know, they're calling this a gravitational lens, and it seems to match. You know, the observations and the models, they seem to match. So it's like, well, okay. This, you know, I mean, there's a lot of distortion going on there. There's a lot of I don't know. It seems to be really bright. So I don't know.
Can they pick any detail out of it, or is it really that distorted?
I'm not sure. You know, we would have to we'd have to investigate this a little bit more to really know. LRG 3757. Maybe we can. Oh, did I? Oh, I know what I did. I didn't mean to do that. I meant to just copy. Let's go over to Sinbad really quick and see if there's anything there. 'Cause if so, maybe we can pick that up tomorrow. I'm noticing that it's getting a little late. Oh, yeah. Well, we'll have to look into this a little bit. Let's do one more quickie. Let's put it in here under abstract, maybe. Come on. Oh, ouch. Title. Yeah, it's probably got another name. Yeah. Yeah, shoot. Well, you know, one more thing.
Why does the Hubble, the HSC calls it that, and you can't find it anywhere else?
Don't ask me. Well, it's got its own Wikipedia
Google
page.
Will travel.
Absolutely. Okay, so the Foreground Galaxy is known as LRG 3757. I guess this poor galaxy doesn't have a name. Huh.
Or a category or something.
Yeah. Okay, well, we'll have to yeah, we'll have to dive into this a little bit, see if we can find out anything about this. I cannot imagine that somebody hasn't studied this thing to death, right?
Somebody will have.
I would think so. I would think so. So these redshift values are, you know, can be interpreted as measurements of distance. So the smaller the redshift, the closer the object is. And I don't remember exactly what the relationship there is, but I can say that a galaxy with a redshift of 2.379, which is this one, is way out there. I mean, is way out there. 0.44 isn't really that far away. I mean, that's pretty far too, but you know, maybe hundreds of millions of light years away. This guy is you know, billions of light years away. So way out there, way out there. But you know, and I don't know if this is true or not. This is kind of an interesting question. If we were in this lensed galaxy, right, looking this way towards our galaxy, I wonder if we would see a similar kind of a thing. Except, of course, it'd be our galaxy being lensed. I would think that would work both ways, right? Because that's sort of how a lens works. So yeah, I would think that from this galaxy's point of view, our galaxy would look lensed as well. Yeah, I think so.
Would that depend on a similar bright object being behind it?
Well, it's not behind it though; it's in front of it, right?
Sorry, yeah.
Yeah, but from this galaxy's perspective, right? This galaxy is in front of us. So that would, that would work out just fine. So yeah, my guess is that our galaxy is being lensed in sort of the same way, and anybody in this galaxy that we're looking at on the screen here would see our galaxy as being distorted like this as well. Pretty cool. All right, well, with that, I'm going to get out of here. I'm going to try to find out a little bit more about this thing, because it was discovered 12 years ago. So here's a reference to the actual discovery, right? So I can look and see how many times and which papers have actually referenced this paper. So I can do that, and that'll help us understand this thing a little bit more. Because yeah, I mean it's looks really cool. It's pretty dramatic, and yeah, the HST data is fabulous looking, right? Really nice. So. And I actually like this nice wide field of view too, right? That's really, really nice. You pack a lot of galaxies in here. All right, that is enough for now. I could go on and on about galaxies forever, but I'm not going to. I'm going to check the chat one more time really, really quick. You guys. All right, excellent. I am going to get out of here for now. I'll definitely, as I said, I'll look into this Horseshoe Galaxy a little bit more, and see what can be done about that. Otherwise, yeah, as I said, I'm going to get up and check my conditions. If it looks like it's going to be clear and the humidity is going to be okay, then I'm probably going to do it, even though I'm not going to be able to see the whole thing. I'll get some good data, at least. I'll get at least an hour's worth. So that's enough, I think. So all right, we'll see. We'll see how it goes. I think it's going to be cloudy and humid. I think it's going to be both. So it ain't going to happen. But you never know, right? All right. Take care, everybody. I will see you in about 22 and a half hours. Is that right? 22? Yeah.
I should make it as well.
22 hours and 31 minutes, to be exact. All right. I will see you all later. Have a great evening, a great day.
Live long and prosper.
Live long and prosper, the whole thing. All right, everybody. Peace, cheers. I will see you later. Bye.